Hi everyone, good morning, good afternoon.
Hi.
It's great to see everyone. How are you doing? Great. Okay. So yeah, let's wait for a couple of minutes for more people to join and we can get it started.
Hi, everyone.
Hello.
Hello.
Hey.
Is that a new logo? Did somebody create a logo for the reading group?
No, not really. It was
Oh.
just a slide that I put together like 5 minutes ago.
Well, it looks great.
Yeah, we actually should start thinking on a logo for us.
So was everybody at the symposium last week, or am I the only one that missed it?
I missed it too.
Oh, good. Okay, great.
Yeah.
I just heard about it this morning.
Yeah, I saw the big group photo, I think, on Twitter. It looked like a lot of people.
This photo?
That one, yep.
Yeah.
Yep.
I think
maybe 80 people in person or 60, I'm not sure. And then 40 or so online.
Yeah, I think I remember seeing there was like a hybrid option, and I just was at the point of being too sick of hybrid meetings, of just being the person that wasn't there, that I decided I don't want to do that unless I was really, really motivated. It's not the same.
I agree. It was
Yeah.
nice. It was a good meeting.
At some point there was like more than 100 people joining online.
Oh, really?
Yes.
Oh, okay.
Yeah, but for sure the experience being there is very good. Okay, I don't see many more people joining, so if you like, we can get it started. So yeah, I just thought that this first session after the symposium was a good time for everyone to catch up in what happened there and probably reflect a little bit on what we saw and what we got from the meeting overall. So yeah, I just put these slides together like 5 minutes ago, literally just thinking on how the discussion can be guided, but for sure, feel free to ask questions, to just comments at any point of this. I'm just gonna introduce briefly what we experienced there, and yeah, the thoughts that we probably can follow in this discussion. So yeah, this meeting was a 3-day symposium. So this is the agenda with the highlights. So during the first day, we had the first session was about the future of data-driven modeling. Then we separated in breakout sessions. During the first session, there were some highlight discussions like lightning talks. Oh no, during the first day, it was longer talks. And after that, we break into the sessions in the afternoon. So the sessions were about inundation modeling, climate change, and land surface processes. And at the end of those presentations that were both from people attending the conference or online presenters, we had time for discussion. And after that, there were some activities like playing ping pong and playing football. It was very nice to get all people together. And after that was dinner. And after that, there was another session from kind of 7 to 9 p.m. So it was a very long day. And we had this very interesting discussion about the unanswered questions in hydrology to be answered with machine learning. So I think Hoshin can expand on this a little bit more. And in the second day, we had the second session. So it was about hybrid physics and machine learning modeling. And then the breakout sessions were about water quality, prediction on extremes, differentiable hydrology. That is a very interesting concept as well. And then we had the subsurface hydrology. So not all of us attended these sessions because there were simultaneously. And and there was a discussion at the end of the day that day as well. And during the third day, that it was almost half day on Friday, we had the session number 3 on machine learning as the consumer and producer of data. And yeah, during those days, we had the lightning talks that were a session of a series of talks, 5-minute talks. Luis had one, many of the presenters had 5-minute sessions, and was very nice because not only professionals who had been working in machine learning for years, for decades, had a space here, but also students doing research work or even undergraduate students. I think there was a talk by a college student also working on machine learning. So it was a very diverse community all getting together here. And there were also some virtual and on-site poster sessions. Most of the people who had a talk also had a poster. And there were 2 machine learning tutorials that happened at nighttime during the discussions times. So yeah, those were simultaneous discussion. And yeah, this is the picture from the people who attended in person. And yeah, all the credits to the organizers, everything was very well organized. And it really encouraged discussion about the machine learning algorithms and data sets that we are using to expand our research. And today, and the main point of our session might be on reflecting on this symposium. So we are thinking on reflecting on our own thinking about the subject instead of reflecting on specific sessions that might take too long for 1 hour session, but probably instead of reporting what we saw, which is interesting, but probably not necessary right now. yeah, probably focusing on main questions that we as a community might answer in the future. So here is just one picture that I took during Professor Kumar's presentation. I'm sorry, I don't have much more other pictures. I was also taking notes, and so it flew by. But yeah, these are some of the questions that we could address today. Or yeah, Professor Hoshin is here, and many others that attended the conference are here. So yeah, just these questions might open some discussion. And that is what I had for today. So I don't know who wants to start the discussion. If no one wants to start, I found some, I can provide something that it was interesting to me. And it was, I didn't know the existence of camels. Camels is a data set that each country is creating based on the example that we got from the US, and then Great Britain now have this large data set where they each country is trying to combine all catchment data sets that they can produce, and putting that in a way that future researchers might find easy to work with this data and apply machine learning techniques on their own data sets. So yeah, for me, it was enlightening because I know that there are a lot of data sets in Colombia that might find a good place here in that kind of data sets. And actually, I was introduced to this by Luis.
I was trying to push Leila that in South America, every country should have this data set. So I said, okay, this is the opportunity there.
Right.
At least related with that was interesting for me was the idea that the Karman, that is now a camel data set, but it's in the entire world. So trying to combine all the camel data set. And probably my guess is that in, I don't know, a few years, in some moment, somebody is going to present a hydrological model using machine learning for the entire world, or at least this is would be the goal. And so exciting, it's very exciting in the future.
So in that regard, Luis, perhaps it's worth reflecting on the fact that your paper shows quite clearly that there's a challenge with the information content of these data sets. Let me actually show people that slide. Let's see. Am I allowed to share?
Yes, you are.
So you guys may remember this. I think I showed it some time back, but basically, as you know, Chile is how many? Almost 30 degrees, right?
Yeah, it's the same like US, but in the horizontal, coast to coast.
So it covers all the way from the Atacama Desert, which is very, very arid and dry, all the way to the south, which is glacial and very cold. And Luis did this work for his master's, where he basically showed, he tuned a GR4J, which is a conceptual physical model, and where he tuned it individually to each catchment. The LSTM, which is a single model for the entire country, and a random forest, which is a single model for the entire country. And whereas most people tend to focus on which model is better, what jumped out at us was the fact that you had this log linear decline in performance across the entire country, regardless of the modeling approach that was used, which strongly suggests to us that while you may have differences and advantages, weaknesses and strengths of different representational approaches, the main issue that needs to get dealt with over here is that the data sets are really only informative about energy limited wet conditions. And the moment you cross over into water limited conditions, the performance just drops very, very dramatically. This is a running average, so the actual variations are much stronger than that. This is like a 15 catchment moving average. So it's great that people want to develop a data set that's global, but if they don't pay attention to this problem, which is an information problem, we're only going to end up being able to do well in humid regions. And so this is actually a challenge for anybody, but for you especially, Luis, is to start asking the question is what's missing, right? What would be helpful when you go to, so this is wet, this is sort of the intermediate region, and this is very dry. And what's actually interesting is that there's a lot more variability in the intermediate region when you get to the dry region, and all the models again fail quite poorly, showing very clearly the lack of some useful valid information.
Yeah, in fact, we are trying to tackle this issue now because we have a project in Chile trying to develop an operational model following exactly the same idea here using the three models. And the question is exactly that: what is information that we need? So we are trying to find different sources of information, especially about, I don't know, gridness. So NDVI or this kind of products, something related with soil moisture, all this kind of information that really is related with groundwater and the humidity that we have. So the condition that we have in the catchment, that's something that is not in the dataset, and probably in the dataset here in Cameroon's US either. So hopefully we could improve that performance using that variables.
So in a
Another
sense,
thing. Oh, go ahead.
In a sense, that's an information theoretic problem, which is why I raised it.
Yeah, would you say it's really like a information bias, or could you just say it's harder to predict those catchments and there is no transferable information, or would that be the same thing in your opinion?
Luis?
In my opinion, it's just information, because given that in that case we have GR4J, that is a Lamport process model in some way, so it's very similar to LSTM. So LSTM we can see in this kind of the benchmark, upper benchmark, but it's almost similar, almost the same. So in some way, GR4J was able to extract almost all the information, but given that there are no more, so that's all, cannot do it better than that. So we need extra information that we need information to tackle all the other processes in some way.
Yeah, but do you see it as that information is there and you just have to find it?
Yeah,
or could it
at
be
least
that
this is
it's
our
just
hypothesis. Yeah,
okay.
because something that, given in the project that I'm working now, I was talking with people in this area, and in some moment he told me something that was very interesting to me that I didn't know it. That, for example, in 2015 we have a very strong rainstorm there in that region, and okay, we have a lot of rain or whatever, but 2 years after that they saw that the vegetation increased and they had a lot of water in some way, but was not related with any other precipitation event. So in some way, this is telling you that there information is about water that is moving from the event that was 2 years in the past.
Yeah,
And just now you are seeing that consequence. So we need that this kind of extra lack information that we are in some way we are not tackling here.
In fact, Luis showed in the paper that beyond about 32 days of memory in wet regions, there was no particular benefit. But when you went to dry regions, you needed as long as a year time delays in order to improve the performance of the LSTM. So clearly it's moving from, well, Luis characterized it as being moving from precipitation dominated to, or short memory dominated to long memory dominated, where, so the drivers are not so much precipitation recently as snow melt or precipitation and so on years ago. So you could think of it as groundwater dominated rather than
And at least my guess is that here in US, we should have exactly the same behavior or the same problem, because I remember that in areas where it's very arid, especially here in Arizona, the performance is the same when you are using canals. So finally, it's the same issue.
Yeah.
Anyway, that's one point we tried to make. Another point I tried to make was, can you guys see that?
Yes.
Yeah.
Okay, which screen are you seeing?
Your
Presenter screen. Like the
Okay, how do I get it to present?
Swap display, the other one.
But
To the
both my
right?
displays are showing presenter screen. Here we go. Is that better?
Yeah.
Yes.
Okay. The other point I was trying to make was people love to show these kind of curves, right? So let's just take any one of these curves. Let's look at the red one, for example. And let's assume that that's sort of similar to what people have been showing for the canals data set in the US. And you're basically reporting the median score, which is about 0.75 in this case. And all of the focus seems to be on improving this median score. And the point I was trying to make was, if you're reporting a median of 0.75, what you're really saying is that 50% of the catchments have performance worse than 0.75. And there's very little discussion being why those catchments are giving such poor performance. So saying, you know, if we really need to get more rigorous in our characterization, and I was just contrasting this with, for example, when Yuan did the snowmelt modeling work with the LSTM model, he was able to show that you could get above 90% efficiency for 90% of the pixels. So, you know, there was still some where the performance was poor, but that's a much stronger performance metric, if you will, than 50%, right? So there's a tendency to just focus on sort of the median performance and then ignore what that's actually telling you about what's not working.
So is it fair to say that we need to come up with new metrics to evaluate performance in our algorithms?
Well, certainly there's that. Timothy Hodgson from the USGS was pushing on that issue, which is great, because we've been talking about developing better diagnostic metrics for hydrological models for quite a long time. But yeah, in a sense, what we're trying to say is that, you know, there's been machine learning for 5 years, sort of the low-hanging fruit has been tackled. Now we need to start looking at the we need to start becoming more rigorous and robust in our evaluations and asking not questions about how do I do this, but why is something working or not working? Switching to a more science-based focus. And ultimately, that's a question of, to me, that's an information theoretic problem, right? It's like, are we, as Stephen mentioned earlier, are we just lacking the information we need? How do we detect that? Or is it that we're not making use of the information that we actually have, which is more of a modeling problem, information extraction problem?
I have a question for Luis. Just a few moments ago, you mentioned a worldwide data set. Were you talking, did you say Canvas?
Caravan, because it's
Oh,
a group
caravan.
of camels. Caravan, so it's a group of camels.
Oh, that's right. Yeah.
Caravan.
Okay, so I heard about that this week. Is that the one that is basically like a wrapper function for Google Earth Engine?
Yeah, I was checking the paper and mainly they are doing that. But finally, given that they have to combine all of them, really what they are using for each country is just a stream flow, because they have to generate all the data set again. They have to define a unique forcing, a unique way to define the attribute. So finally, it's just a stream flow plus another extraction from the Google engine that for different data set. But this is the idea.
Yuan was also at the meeting. Do you have any thoughts or comments from the meeting, Yuan?
I was just feel a lot of people are working on very similar ideas. So like Professor Shen, their group, they propose differentiable hydrology framework, but that actually was already appears in Jiang 2020 GRL paper, right? But I think the good thing is like just Luis what he showed the result of the no matter the model inadequacy or the issue of data. I think it's good to see the community is moving to trying to optimize the algorithm, not just only use the existing network. That's how I feel. Although I think we still have some room to improve because we are right now improve the algorithm based on the existing theory, but maybe eventually we can do a evolutionary type of really optimize everything. I don't know.
Yeah, I agree because I saw so many LSTM models and applications. It was just like, is this the way how we should continue working? Like, adding new data sets to the same algorithm?
Yeah, I remember I had a talk with a guy that is really a data science. So he was asking me, why in hydrology everybody's using LSTM? Why? There are more algorithms there, but everybody's using the same. So I said, okay, this is kind of the simplest one and it's working. But so in some way, given that it's working, we are okay. We are comfortable with that, and we don't want to move from that.
I should point out that Luis and some others have been doing work to try to see if they could improve on the existing LSTM architecture. So Luis gave a talk about what he calls hydro-LSTM. Maybe you could show that sometime to this group.
Yeah.
Also, I should mention that Freddie and Jonathan and Greg contacted me because they have their, what's their package called?
Neural hydrology, maybe?
Neural hydrology software package. And they're planning to I guess it's already available, but they're planning to put it out there so people can have direct access to the code and, you know, optimized code and all of that. They're planning, I suggested that they need to put some kind of tutorials together on how to use it. So they're going to use me, at least as one person, as a guinea pig to go through it, because I want to start using it in the new machine learning course I'm developing. But the idea is then they're going to put some YouTube videos and stuff like that. And then in principle, as people make changes and improvements, they can add that to the neural hydrology package. Xiaoping Shen's group is also doing something similar with a LSTM package, I believe. Yeah.
So it seems that beyond machine learning, it's more neural networks what is going to be the leading the future research, right? Like deep learning.
Say that again.
So beyond machine learning as it is more neural networks and deep learning what is leading the future of the research, right?
Well, my view is that there isn't a strong fundamental difference between traditional directed graph modeling of physical systems and machine learning. It's just that machine learning has a lot of optimized technology, which allows you to go beyond just specifying the structure and learning the parameters to actually being more explorative in terms of system structure and so on. Firstly, I think the missing component is what our community can bring to it, which is that there's not been a strong influx of information theory into practical domain applications of machine learning. So all the models out there are essentially highly inefficient. They don't attempt to do any compression at all. And so now they're dealing with the problem of how do you interpret the results that are coming out of these models. There are very, very few papers which are using minimum description length as a guide for model selection.
Yeah. It also seems like somehow it doesn't apply to these models because, and I'm not sure if someone really understood that already why this happens, but if you look at the number of parameters they use, yeah, it seems ridiculous, but it works.
Oh, just because it works doesn't mean that it's efficient, right?
No, but in principle, the minimum description length principle is not just about efficiency, but also about whether you can actually extrapolate things, right? And
sure. Well, there's strong regularizing effects of machine learning structures, and there's a strong. I rather suspect that one of the reasons why large networks work is because you're essentially doing global optimization when you toss in a very large number of nodes. But what people are not doing is pruning. So when you throw in a large number of nodes which are randomly initialized, that's essentially equivalent to doing a lot of small optimization problems simultaneously in parallel.
You could end up with very different models that all perform reasonably well.
That's right.
Yeah.
Right. But I've seen papers, at least one paper where they used MDL as a selection criterion and showed that the model that they got was both more interpretable and at higher accuracy rates when tested out of sample.
Okay. Was that is that also related to LSTMs or to this AI Feynman type of?
They were actually using genetic algorithms to select for structure.
Okay.
And activation functions. Yeah.
Was it this Techmark or Texmark?
No.
Group or?
I can send you the paper. It's
Yeah.
by a group out of Noor, I think was his name. I think out of Israel.
Okay. Yeah, it would be interesting.
And it's an interesting paper because it actually gives some explanation of how they did the counting, which is still somewhat arbitrary. So he assigned sort of arbitrary costs for different kinds of activation functions and so on. And he came up with, and I guess the basic point is following from Risanen's work is that any reasonable way of doing description length counting is okay. You know, it's not rigorous in the sense that they're counting every single addition and every multiplication and assigning a specific bit length cost to it. They're assigning bit length costs, but they're being done in a somewhat more subjective or arbitrary way, but in a way that's sort of reasonable. Which at least is a good start. You know?
Something related with that, I remember a presentation, probably Professor Bipin Kumar, that in some way he took the camel data set and he took all the attributes, that there are many, and he compressed the information. And he showed that really, we don't need this large number of attributes. We need a little less, probably. I don't remember the number, but was less than that. And in fact, the compression that he did, in fact, he learned it, was better, better in the prediction than the attribute that we are using.
What was the author of that paper you said?
Vipin Kumar.
Yes, Bipin Kumar.
He's doing knowledge guided machine learning, sort of his thing. KGML.
Yes, KGML. The talk was a new framework for accelerating scientific discovery.
Anyway, so I do think there's a lot of scope for a marriage. As I tried to point out, I think the missing component is computer science. So we need computer science, machine learning, information theory, and domain science. And we need to figure out how to do a proper marriage of all four of these components. But even two at a time is not bad. So.
Yeah, one of the discussion questions in that session was, what should be the holy grail of physics-guided machine learning or differentiable hydrology?
So what did you guys understand by differentiable hydrology?
In my understanding, they are trying to impose physics to already existing algorithms in machine learning to be able to put some physics guided constraints to what machine learning does. Yeah, but I need to
nothing to do with differentiable, right?
Right. Yeah. The word is a little bit misleading for me, but yeah, it's more physics guided. But I haven't read his paper, so I need to read his paper to go more into the details. But from the talks, yeah, for me, I remember more physics guided than differentiable.
I mean, the word differentiable is kind of an oxymoron in a sense, because really all that he's saying is that he wants to use backpropagation to learn everything.
Mm-hmm.
That's machine learning. So you basically have I'm aware of only two strategies for learning. One is backpropagation and the other is genetic algorithms. So right now backpropagation is cheap and genetic algorithm is expensive, but eventually you're going to end up with a marriage of the two, because backpropagation can only do part of the optimization problem, and genetic algorithm is what you need to do the other part. So guess the other thing that Praveen and I were pushing was that there's a lot of focus on how, and we were saying we need to switch the focus to why.
I remember a talk that somebody was presenting the comparison between LSTM and a transformer, and finally the performance was almost the same. And I said, okay, so but why they are different? Why we should use one or another? But they didn't know. In some way, this is what's happening now. Somebody's trying to test different architecture, but really we are, or at least I have the feeling that people is not pushing too much in the idea to understand why one is better, or in what cases one is better than another.
So a lot of papers are, I've got a hammer and I'm going to use it and I'm going to report it.
In some way, this is what's happening. We can see LSTM everywhere because they are just, okay, we know LSTM and we're applying everywhere.
Yeah, I think one of the, like after reading one of these papers, my hope is to find something new, right? Like what is telling me different that I didn't expect or I didn't know before. But actually the focus is more like, and we reduce this much the percentage of uncertainty from code that was used before or something like that. So it's not actually breaking anything. Yeah, it's not advancing science, like for some of them. Like there are also a lot of very good literature, but yeah, I think the focus shouldn't be focused too much in the percentage of uncertainty that we are reducing by using this or that algorithm.
Well, I mean, the first thing is always going to be how much water can I squeeze out of the stone, right?
Mhm.
So, you know, when you get to the point where you've pulled as much information out of a data set as you can, but then you got to go back to why you started doing this in the first place.
Agree. During the first day, at the end of the day, we had the discussion on, let me see. I think you were one pushing one of the hosts in that session, in the breakout session. Let me see the name. I think it was very interesting. We discussed what are the unanswered questions in hydrology that could be answered by machine learning methods in a unique way. So do you have any outcomes from that discussion that you want to share with us?
Oh, I honestly don't remember much about the discussion. I was mainly focusing on trying to get people to answer, to justify their. So what Tirthankar and Dipankar did was they basically had a question and they gave a bunch of answers and they asked people to go on some kind of web thing where you go and you put your answer and it counts all the answers. And we were using that to stimulate. And then I was saying, well, who answered this and why? And, you know, using it to stimulate the questions. But generally the idea was sort of like trying to say, and we should do something similar in a sense. How is machine learning going to help? Right? What are some of the low-hanging fruit? What are some of the things we can tackle with machine learning? And so what kind of questions in hydrology is trying to stimulate thoughts about what kind of questions in hydrology could we tackle using machine learning. I guess a fair question also would be to us, why do we think information theory is useful? How is it going to help address problems in hydrology? What did you put up, Praveen?
So recently I came across this thesis, which I shared with a few of my students. The first link is information flowing deep neural networks. And the others are basically papers out of that thesis. So if somebody didn't want to read the thesis, could read those papers. But this is an effort to link information theory with machine learning, neural networks, and it's less enough applied and more of a theoretical foundation. So I like those kind of papers because they give more insights than I can improve my prediction by X%.
By the way, this is the information bottleneck paper. that we talked about.
It's based off of the information bottleneck idea. I think it builds off of that.
Yeah, I'm saying these are the papers that I'd mentioned when we got together to talk
Right.
about.
Yeah. So one of the things we could do is maybe systematically read through these things over the next few reading sessions, because given the interest that is there in our group in bridging the two, this might be a useful thought process, particularly because we like the information bottleneck paper so much and it was insightful. I think these could provide additional. The last one, basically, third one is it, which links to, talks about a dual information bottleneck.
Sure.
So it'll be useful for us to read through these ideas there. I know I've asked some people in my group, Tarun and Harsh, to be reading that. Yeah.
So these papers had led to a controversy in machine learning community because they proposed that there were sort of two stages to the learning process, and it led to a controversy, which I reviewed briefly when we talked back then about what actually was happening in the deep neural networks during the training process. Yeah, it would be useful to review those.
Yeah. So controversy is always good because it tells you that these ideas are not settled and there is some nuances that need to be probed deeper.
Well, there was a fundamental issue which had to do with the ability to measure entropy in mutual information. And part of why I think the debate sort of died down was because nobody has a good way of being able to accurately measure the quantities that they wanted to, that they would need to measure in order to be able to resolve this controversy. Everybody's using basically some kind of binning method for measuring information measures, and you can make the measure be anything you want just by changing the size of the bin.
Do you have any references for that controversy? Is that something that was debated in the literature or more offline?
No, it was in the literature. If you go to my my review of information bottleneck at the end, there's a bunch of citations.
Okay.
References on that controversy. Some of these papers, by the way, never made it into. This is an interesting example of papers that don't that they couldn't get published, but which are very good and highly cited anyway. So let me bring up another issue for general discussion. I've been talking with Uwe about the next, and Praveen and others about the next workshop that we couldn't organize this year for various reasons. And the plan now is to try to organize it sometime next year, but back at the Schniefer House in Germany. Stephen's very happy about that. The current thinking is that we will try to do it sometime in September of 2023. Just giving you a heads up. Part of the reason being because my plan is to be visiting UI at that time. There were other dates proposed, like around EGU and so on, but sort of starting to feel like it will most likely to happen around that time. And one of the things we should be thinking about, first of all, if it's a problem, we need to know. The second is, do we have any strong thoughts about focus? How do we focus that meeting? Which would also affect whether we invite anybody to come out there, things like that. Any thoughts, comments?
Can I offer a thought for maybe along those lines? So I'm at EGU in Vienna right now, and I've noticed in the short courses in the talks, I've looked through the program extensively, and there isn't much talk about like computer science. And I think this trend of having, or this idea of having a hammer has to do with, I think, a need for better understanding of like real computer science. So I keep running into these things or like computer science questions. And to me, it's frustrating, but it's also kind of exciting because it means that, yeah, there's not just some simple solution, but definitely having a better understanding is something that I strive for.
So when you just want to be clear, when you're referring to computer science, you're not talking about programming issues and so on. What exactly? We should be clear about what we mean by computer science. So that
Yeah,
talking about the same thing as you or not.
Yeah, I mean, looking at a problem and understanding the complexity, understanding the implications of algorithms and like down to the hardware level. Because I've spent a lot of time trying to do things. I just kind of go in circles with different tools because of things like memory allocation. I've been dealing with that recently.
Okay. So that's more like implementational issues, challenges, which obviously come up. Yeah, when I say computer science, I'm thinking more about the theory of computing, which is foundational to information theory and algorithmic information theory. In fact, there was an interesting paper I sent a few people, which was discussing what's the difference between an equation and an algorithm. And it's a really interesting. It's a really interesting point because conventional views of physics think in terms of establishing equations for things, whereas the computational view of the universe basically says equations are just emergent properties of algorithms. So algorithms are more fundamental in some sense than equations. And everything we do when we compute, even when we say we're going to use equations, when we actually do our computation, when we actually solve them, we actually use algorithms. You know? So there's a whole field of computer science which has to do with the theory of computing, and which is really the theory of how you build models. And to me, that's information theory. So.
Yeah, so I posted this link, which I came across recently, and I shared with a few people. And this where some young assistant professor has been awarded about a $15 million grant to develop computing with living neurons. So the artificial neural network can take a hike when you can do actually with real neural networks. And obviously there is some proof of concept that exists in there. I haven't yet looked into that, but if you can start computing with that kind of a thing, then it's going to be a game changer in there. How that will be realized is yet to be known in there, but that's a reasonably good investment to start doing proof of concept technologies in there. Right? So as we are thinking about simulating a neural network, these guys are thinking about using an actual neural network
Nice.
for computing. So I suggested a theme for the meeting. I mean, we can revise and iterate, but I think that might provide a framework to keep talking about the information theory, but also bring in some of the newer concept in machine learning AI. I'm always interested in what new can you do with that, right? I mean,
Right.
it's not doing the old stuff better, but can it help us answer different set of questions? If it helps us answer old set of questions better, fine, but that is not the thing. So, I mean, if you can set the stage with some invitations and other things, we could do that. Just a suggestion. I mean, open to other ideas. So.
No, I like it.
Yeah, I like it.
Personally, I think one of the things that MLAI, where MLAI and information theory overlap, is in the problem of determining minimal sufficient statistics, which I think is a core issue. We've always had to guess at them, but using autoencoding compression techniques, in principle, you can actually solve for them. And that's back to your information bottleneck thing again.
Yeah, and I'm also thinking about causal inference as well in there.
And then if we can also link it to thermodynamics, we have our original themes back, all linked to machine learning. There's probably some connection, right?
Oh, there is. Actually, if you guys are interested, you should look up Josh Bach, who's a computer scientist. Joscha, I think. Yosha, I think he pronounces his name. Yosha Bach. I think he got his degree at MIT, and he's now the head of some, in charge of some computing lab somewhere, some private company. But he has some very deep thoughts about the computational nature of the universe, how physics arises, and why a discrete computational representation of the universe is more fundamental than continuous representation. It's interesting if you guys want to go and listen to something really interesting. He has great thoughts on the matter.
Another thing that I am thinking that could be a potential fun project for us is to come up with a dictionary of terms and ideas, because I think sometimes the language, how we express, as Hoshin said, is important, of course, but it is well managed by people who have been in this field for a long time. And so for new students to be able to quickly catch up on the real meaning of what we are saying, and even for us, for me, it will be helpful to have like a 101 dictionary of machine learning / information theory perspective of the geosciences research or something like it. So yeah, yeah, it's kind of a fun project.
It would be difficult, but the act of doing it would be very valuable. There's a computer science concept right there. You have to start with a dictionary.
And then we can invent very short words for all the things we most often talk about and shorten our meetings by 50%.
We'll have to start calling you SW.
Yeah, there's no reason why entropy should have 3 syllables.
So Praveen's made a proposal. We've been talking about, where do we go? Sort of energy seems to have died off a little bit. And we haven't had much in the way of presentations or discussions recently. What do you guys think? You said you'd given those papers to your students, Praveen?
Well, I gave the thesis, so maybe Tarun can lead it off.
I was going to ask if maybe you could start with that, yeah.
Tarun, what do you think?
Yeah, sure.
So let's pick one of those 3 papers. So I would say not the thesis, that would be too long for everybody. And then maybe discuss, let Leila know, and she can send it out. And then 3 weeks from now is when?
Should be the middle of June.
It will be
15.
15th June.
June 15, yes, right before Frontiers in Hydrology
Yeah.
for the ones attending.
So we could do that. So Tarun, you can lead that discussion. So read one paper very carefully, make a presentation, and Leila can send it out tomorrow to everybody. And then I think maybe picking up a couple of those would actually help with this. I'm intrigued by this dual information bottleneck there. That's the 3rd link in that list up there.
If I remember right, that's about having relevant to this, but not relevant to that. If I remember right, let me look at it.
We haven't done this, right? The dual information bottleneck. We did the information bottleneck.
I'm just looking. No, we haven't done this one. The variation of.
So I just found that. So why don't we do the following? Tarun, I think Hoshin, you had done a pretty elaborate write-up on that, right? Information bottleneck paper. Was it you?
Yeah, you've got my slides and
Right.
thing on the online.
So Tarun, you can dig that out and then augment that with what they're trying to do in the dual information bottleneck, right? And I think that would be a useful discussion for next time. And then after that, we can probably pick up one of the other papers, which is either the 2nd or the 3rd link or the 4th link.
I like the idea of going to the representation, compression, and generalization, because that's a more recent 2018 paper. So it'd be interesting to see where things have gone. Interesting comments. The authors admit the paper was not written carefully enough and requires major rewriting. There are, I mean, there's people in the math community trying to dig into this stuff and, come up with explanations for why machine learning works and so on and so forth. They tend to be highly technical, unfortunately.
So what can be done is, this was written in 2018. And I'm going to assume that the thesis would have clarified a lot of the stuff that are raised in this thing. So maybe the right thing to do is to go to the appropriate thesis chapter and look at that instead of reading that paper. Let me see what they have.
Fair enough. And if somebody would like to present the newer paper on using minimum description length to train neural networks, that'll be another interesting one for us to talk about.
Yeah. So that representational compression is chapter 3 in the thesis.
Okay. Did you send out a copy of that or a link to that?
It's the first link in that list.
What is the first link?
Yeah.
I thought those were all archive. Oh, because it's on archive? Is that the point?
The thesis is on archive. So the first link takes you to the thesis.
Information flow in deep neural networks?
Yeah, that's a thesis.
Okay.
Yeah, so it has all the other papers as well. I mean,
Okay. So that's a good start, or a good reference anyway.
yeah. So which one do we start with? The dual information bottleneck next time, and then the representational compression subsequently, or the other way around?
No, let's start with the dual. I mean, let's sort of go in order. It might be better than trying to go backwards, right?
Yeah, yeah. Well, the dual is the last chapter in the thesis.
Oh, I see.
But that's okay. I mean, I think because it's published as a paper, there should be some independence to that, right?
Well, let's let Tarun decide, because he's going to dig in and he'll know what makes more sense, right?
Yeah, I will read both the papers and then see which one comes first.
Okay, and then you let us know, and then is there any volunteer for the second one? Or maybe the two of you can then decide who does what. Who hasn't presented before? Or led a discussion, I shouldn't say this, presented. Nobody's volunteering. Okay, let's take it one step at a time. Maybe we could make it interesting next time.
All right, so we're going to focus on overlaps between information theory and MLAI, or we're going to propose that as a theme for next year's meeting. And that gives us plenty of time to figure out. I like your idea of the dictionary, Leela. Maybe you want to give some thought as to how we could start constructing that. In a sense, it feels like we would need a place where you've got the terms, and then you would need to be able to click on them and go into a deeper investigation, not just a line of definition, right?
Right. I was thinking like probably many people contributing to what is the definition of what people think it is, and then the description of what people who have been working on that for a long time, they decide what it is. Yes. Something like that.
The other thing I discussed with Praveen that might be useful for us is if we started a kind of a page where we encourage people to post papers, but not just post the paper, paste a summary of the paper, you know, like one paragraph or two paragraphs or a page or something, explaining why they think people should read that paper or what was interesting about it. That could also serve that kind of purpose of the dictionary in some sense, well, or going in the same direction.
Didn't Ben have something like that on the geoinfo theory website, or maybe, let's see. Oh yeah, here's resources and a library. Oh no, that's not very extensive. A reference list. But
Yeah, the first meeting, we collected a whole bunch of papers and we put them in a place and people could download them. But I'm suggesting something which is closer to why we're having this this group, which is we're not all going to read all the papers. The whole point was to spark discussion by saying, oh, I ran into something interesting, and so here's why I thought it was interesting, and put a little summary or something off it up, so other people could get an idea without having to go in and dig in through what is sometimes very technical stuff. Magazine. How math can improve your Whittle score. Okay.
It just came across while we were talking.
Okay.
Alison is always looking for such interesting anecdotes.
This reminds me of Ty Foray, who, after his sabbatical, he came back and gave a post-sabbatical presentation where he was comparing inference and groundwater inference to Sudoku, the problem of solving the Sudoku puzzle.
Grant Sanderson's his video on that topic on Wordle. I had information through. I thought it was fantastic. I don't know if you've seen that. Is it 3 blue 1 brown?
yeah,
channel?
I just was
It's
looking
great.
up the link.
Yeah,
I posted it in the chat.
All right, so probably that's good for today, but we should just sort of remind people that we hope that everybody will take turns. So you don't have to read the papers we're suggesting. You just have to find an interesting paper. It would be sort of fair to everyone else that people participate by also volunteering to lead discussions or present papers. Fair enough. I guess we should congratulate Stephen.
Yeah, congratulations.
Thanks.
Awesome.
And Uwe is not here, but Uwe also, he finished his like second habilitation or whatever it is. Now he's gone on holiday this week and he's feeling much more relaxed.
Nice. Yeah, I'm planning to go on sabbatical in Europe from September, so I hope I'll have a bit more time for research again.
All right, Tarun, you are on for 3 weeks from now.
Yes.
Okay.
Yeah.
And Leila will send out the details. Leila, did you get any more sign up after the meeting?
Yeah, like 5 people right now, but I am planning on sending an email to the organizer. So we probably, people don't remember our name or something. And so probably if we send the email, we will get more people.
Yeah. Sounds good. Yep. Tarun, if there's anything I can help with, let me know. My overview of that was fairly superficial, but if there's anything I can help with, let me know.
Yeah, and we also have the video when you share your ideas on bottlenecks, so that would help.
Leela, it's on the YouTube page,
yes,
right? Leela?
It is
yeah.
there. Yeah.
Yeah. Yeah, and my happy to share the PowerPoint slides too, if you find that useful.
All right, I'm gonna head out, folks.
Yep.
Right.
Thank you, everyone.
Bye,
See you
guys.
in 3 weeks.
Yeah.
Have a great summer.